Cost efficiency is a huge advantage, but there are many other reasons enterprise companies are migrating to MariaDB. Vendor lock-in. Oracle can lock you into their ecosystem, and suddenly you can feel completely at their mercy. MariaDB gives you the power to take back control. You get to shape your database strategy in a way that makes sense for your business, with the freedom to take your database anywhere and feel confident in the autonomy an open source database provides you. Flexibility and control. With MariaDB being open source, the possibilities are really open. If you've ever needed a bug fix or customization in Oracle, you know how insanely expensive and incredibly long that process takes. It's vastly different with MariaDB. We are much more agile and flexible and put our customer needs first. Customization is very possible and realistic with us. But because we're open source, if you have the desire and skill set, your team can tweak, extend, or build exactly what you need and contribute it back to the source code. You're not waiting on a vendor's roadmap to align with your priorities. This is your database, and you're in the driver's seat. Performance. If you're running high-demand applications, MariaDB can handle it. With enterprise-level performance and flexible workload options, like with our column store engine for analytics, or the fast processing speed of our MyRock storage engine, it's built for both heavy transactional workloads and the modern-day processing of data. I've seen this firsthand. MariaDB doesn't just keep up, it leads the way. Effortless transition. With MariaDB's Oracle SQL mode, you don't have to start from scratch. It's designed to help you preserve functionality and save time during the migration process. This mode is like a bridge, letting you move forward with modern open source technology while minimizing the headaches of migration. It already supports Oracle language, syntax, functions, and PLSQL. So in the end, this decision isn't just about cutting costs or escaping Oracle. It's about positioning your business for long-term flexibility, growth, and innovation. Minimum high availability should look like with MariaDB. So we have that application and we have that MariaDB database server, but we also have redundancy of those things, not single instances, but in this case, multiple instances of the application and 3 full copies of the database. We're also going to add to it MariaDB max scale and some enterprise connectors. And that will give us some advanced routing and orchestration features, which will help us out in keeping that high availability. And we'll go into that demo in a few seconds. Now, I'm not just going to spin these up and let Hurricane Fred come along and take out this data center. I am going to make sure that I put these servers in separate data center zones. All 3 of these in zone A, B, and C in different areas of Florida with a very high network bandwidth between them, but at least mitigating the risk of all 3 of them being taken down at the same time. I also need to be very conscious of making sure that there's a share nothing for my hardware elements. So all of these databases have their own drives that aren't shared and servers that aren't shared. And then for databases and max scale and my application layer. And I want to make sure that we're going a step further and I have multiple drives on each of these databases, which are independent OS layer, data directories, and log folders. And I do this to try and mitigate single points of failure. So if my log drive fills up, the OS layer isn't going to crash because it's all on a single drive and I've run out of space. So the more we can do to eliminate single points of failure and eliminate shared architecture hardware, the better off we will be in making sure the system doesn't go down. So now that we've had a peek at the big picture, let's zoom in on this max scale layer so that we can begin to understand the magic that max scale brings to high availability. To do that, I'm going to start us off with a simple architecture diagram. You will see that we have 3 MariaDB database servers, and these will have full copies of our data on them. So they're clones of each other, and this is done via standard bin log replication. We place max scale between the applications and the database to do many tasks: load balance, connection routing, automatic failover, and orchestration. And that's how we're going to achieve high availability. So if anything happens to one of these backend servers, max scale is the magical workhorse that detects those failures and handles all the internal mechanisms to keep your applications running without errors or downtime. And don't just take my word for it. Let's watch max scale in action with a quick demo on automatic failover and high availability. I love repeatable demos, so you can actually run this demonstration yourself. Here is the link to the GitHub repo. Basically what I've done is written some Ansible and Terraform scripts that when executed will spin up our demo servers, pre-installed and configured with everything you need to repeat what I'm about to show you in AWS. So I have already run that script earlier today, and this is the architecture currently running in my AWS account. Just like I showed before, I have 3 database copies using that standard replication. I have a primary and 2 replica nodes of MariaDB, just so that we're avoiding single points of failure, as that has been an important element we've already discussed. I'm not just going to have a single max scale node. I'm going to avoid that single point of failure and have 2 max scale nodes, which have the MariaDB connector using sequential failover, and we'll get into that in a bit. Let's look at these 5 servers in AWS real quick. So here you can see in my AWS account, those 5 servers are reflected here. I've got the 2 max scale nodes and MariaDB 1, 2, and 3. Okay, so here we have the max scale user interface, which gives us a very clear dashboard showing all of those servers that we have connected in AWS and their health and status. So that MariaDB 1 is currently master or primary, and I have 2 replica servers, just like our diagram showed. They are all in a healthy running state, and they're 0 seconds behind master. I've got an application running against it right now, so these GTIDs are going to be increasing with 10 connections. Just running a little bit of load so we can see it actively doing things as we prepare for our test. Let's start with a command line stopping the service of MariaDB on that primary machine. So here is at the bottom of the screen our MariaDB 1, and I'm just going to do a quick systemctl stop MariaDB, and let's see what happens. So my refresh rate on the dashboard is every 5 seconds. It would have happened much quicker than we actually saw in real time, but MaxScale detected that master went down. It elected a new master and promoted a replica to be a master and made all running slaves now all those running replicas a replica of that primary. So now what happens when this MariaDB 1 that used to be a primary comes back online? MaxScale detects that it's back online, and it makes sure that it's not going to try and compete for master status. It tells that node, that newly recovered node, that it is now a slave or replica of the master, which is MariaDB 2 at this point. So all of this done automatically. You could be sleeping while this failover is happening automatically for you. So that's great. Maybe that's an application, database level outage. What happens when I just pull the plug? Let's take, this is currently the primary. All of these are running. Let's just take the instance state to stop. There we go. Almost instantaneous. Our refresh rate flipped over pretty quickly there. MaxScale detected the down and promoted MariaDB 1 to be the running master. Okay, so now it's officially stopped. I'm going to start that instance back up. And once it comes back online, we should see it join as a replica, a slave here in a second. And again, this isn't dependent on MaxScale waiting to add it. It's dependent on that server coming back online. So as soon as it is available, MaxScale will see it and make it a replica. And there we go. So what did we just see? Going back to this architecture diagram, what was happening behind the scenes here? So we had that application layer, that was those 10 connections we kept seeing, which was connected to MaxScale 1. When that primary went down, MaxScale 1 promoted the MariaDB 2 to be a primary node and stopped routing any traffic to MariaDB 1. It also told MariaDB 3, the other replica in the system, MariaDB 2 was the new primary. When MariaDB 1 came back online, it didn't compete for primary status. It wasn't running its own write logs or getting out of sync. MaxScale 1 detected that it was back online and immediately changed it to a replica and waited for it to get back in sync before it would ever route any traffic, like read traffic to it. The question is, what if a MaxScale server fails? Why do we have that secondary server there? How does that play into our high availability solution? Well, I just told you a little bit about that cooperative lock. So if MaxScale 1 were to fail, that cooperative lock would disappear. It's actually a little record in the back end of these servers. And when it disappears, that record disappears with it. So the other MaxScale, which is checking every few seconds, depending on your configuration, it's checking for that lock exclusivity. When it detects that there's not a lock in the back end of these databases anymore, MaxScale 2 will take that cooperative lock, and now it is in charge any orchestration in the back end. So you're covered. There's no no failure that's going to happen. You also see that this sequential failover connector up here in the application, it actually has a string that has both IP addresses of both max scale nodes, and with sequential, it will go to that first max scale node, try and route all traffic to it until it can't anymore. And just like in this diagram showed, if it's not available, it uses the second IP address. So it will also automatically go to that new max scale node. So we're safe from single points of failure here. We have redundancy, we have failover mechanisms, and the application is going to stay online and accessible through all of this. Let's take it one step further. Now, without max scale, usually even planned outages, whenever you're failing over from one database to another, there will be some kind of network blip outage, probably some connection errors that get sent back to the application. Well, not with max scale. Max scale, when configured to use zero interruption automatic failover, connection migration will automatically migrate a backend connection to the new primary if automatic failover occurs. So without this, the application's connection closes, requiring it to create a new one. So this can cause an error. If you don't have this turned on, it requires the application to reconnect. We don't want that. So connection migration is very important in this zero interruption failover. Session restore is another great feature of max scale. If failover occurs and there was a previous session state happening on that connection, it's not going to get lost when it fails over. That session gets reissued on the new primary so that your state, your session state, is not lost in that failover. Finally, transaction replay. If the server failed mid-transaction on that primary and it was unable to complete, instead of having to roll back and have to have the application be aware and re-execute that transaction, MaxScale saves that transaction playlist, and when that new primary takes over, it will replay those executed queries in that transaction so that you're back mid-transaction when it failed. Without this, you end up with transactions rolled back and the application is responsible for retry. MaxScale handles all of this. So virtually, failover is seamless to the application because all of this is done behind the scenes by MaxScale. The application doesn't have to know anything. Now that we've seen the magic of how MaxScale solves those high availability challenges when unexpected failures happen, let's go back and look at the topic more holistically. What does high availability and disaster recovery mean for us? What does it mean for you? What things should be considered in every production environment architecture design to be prepared for the worst case scenarios? What do you need to be thinking about? What do you need to be planning for? And what do you need to be prepared for in the case of these disasters? We need bulletproof architecture planning, right? We need to address both high availability and disaster recovery. Another way of looking at this is database availability, right? And we can look at uptime. How many nines? And we'll dig into that in a second. How much uptime do we require? How are we going to achieve automatic failover? Which we just saw, we can do a lot of that with MaxScale. How are we going to achieve connection automatic failover? How are we going to attain system redundancy so that there's something to fail over to? These are all important elements to database availability. Now looking at the other side of things, that's keeping the system up, right? But what if all of those systems go down? What is our disaster recovery plan? Another word for this would be, what is our data recovery plan? Do we have backups? Where are those backups located? What kind of backups are they? Do we have point-in-time recovery? Can we roll back if something happens? Do we have deletion recovery, a way to retrieve records that have been deleted off the system, accidentally perhaps? Do we have data redundancy? Where is that data? Is it safe? Is it in multiple locations? One of the biggest errors I see and potential failures I see of customers is they take a backup, but the backup is stored on the same system as the database. So if you were to lose that database, if that server was compromised and you were unable to access all that data, your backups would be lost. So you need to have multiple copies of your backups. You need multiple types of backups. You need multiple strategies for those backups so that when the worst happens, you don't have a single point of failure in recovering that data. So what is your business tolerance for downtime and potential data loss? Now, everyone is going to want to say 0, but the reality is 0 is expensive. We need to be realistic about what that tolerance actually is. So let's have a little reality check here on uptime. 9s. How many 9s do you need? Let's look at what that boils down to. Okay. Uptime for 3 9s is going to amount to a downtime of just under 9 hours a year. Now, per month, that's 43 minutes a month. Per week, 10 minutes a week. 4 9s, we're quickly reducing that amount of possible downtime to 1 minute a week. 5 9s, down to 6 seconds a week. 6 9s, we're in the milliseconds, and that amounts to only 31 seconds per year. That's no upgrade downtime, no network blips. That is a very lofty goal. So what can you actually tolerate, right? What can the business afford to have outage per year, per month, per week? So can you really afford 5 9s, let's say, of 5 minutes in total for a year? What does that actually cost the business? Because as we'll see in a second, it's going to have a direct correlation on what we can build and architect to get closer and closer to that 6-9 standard. Note, though, that even if you have weekend maintenance hours, you still might need several 9s of availability Monday through Friday. Even if you can take a planned outage on a weekend, your business may not have the tolerance for more than 5 9s of outage during business hours. Now, the other component to building our high availability architecture and plan is the data recovery objectives of the business. So what that means is how much data loss can the company afford? If you're running business, that recovery point objective, that data loss, is probably 0, right? You can't lose money or transactions ever. On the flip side, we also have to be aware of what is the downtime recovery time objective. How long can we be without those records in the case of an outage? So when disaster strikes, when that hurricane hits, how long can the data loss impact us? Can we withstand a few seconds of data loss? Can we withstand a few minutes of transaction data loss? If we can only take a few seconds, how long can it take us for our recovery to get those records back? Do I have minutes? Do I have hours? Do I have days? As long as I get those records back, what is my tolerance? So we need to be very aware of where the real business need is so that we can build this business plan. Now I have a acceptable recovery time objective, realistic recovery time objective, and a realistic recovery point objective. Now we need to correlate that with how much can the business afford to spend and how much can't it afford to lose in these scenarios. The greater the cost that we spend to prevent these outages, the more we spend on getting several nines, the greater our architecture complexity, the shorter our duration of an outage. The less expensive, less complex solution is going to have a greater cost to the business in the case of an outage because it will take me much longer to restore. Let's look at our tolerances. So here we have an acceptable recovery cost, an acceptable amount that the business can afford to spend trying to get several nines, but also a recovery time objective of what is tolerable for data and outage loss of that business impact. Now, once we have all of these numbers, all of this tolerance, we can actually look at potential designs. Multi-site, active, this is going to be several servers in multiple data centers, in multiple regions, all active, all running, all consuming resources. This is going to be one of your most expensive solutions, but it will get you several nines. You can also have a warm standby. That DR site can be ready to go. Or maybe it's just a single pilot light, something that can easily be spun up to something larger, more servers. You can see how we're getting less expensive, less servers, less resources. Maybe your tolerance for outage is much higher because you can't spend a lot on this project. Maybe a backup and restore is your only disaster recovery solution. Now we've seen how MaxScale can help us with high availability design. Now let's spend a few moments talking about data recovery options. So how do we protect your data and plan for recovery in the case of data loss? First and foremost, backups. You can take hot backups, which are highly recommended. Enterprise backup, Enterprise Maria backup is great. It's non-blocking. It is a file level backup while it's still consistent because it tails the bin log and replays them on restore. What configuration of that are we going to do? How often? We need full backups, maybe weekly. Incremental backups, maybe daily. And then bin logs also as a component of that so that we can rebuild with a full backup, incremental backup, and bin log backup. Now, you don't want to do a full backup every hour because that's too much on your system. Realistically, you need a combination of this to be successful. You can also be taking cold backups, such as snapshots, where you need to do a little bit of configuration and pre-snapshot and post-snapshot scripting to make sure that your backups are going to be consistent. But snapshots are a great way to take a backup of your system, especially when you're talking about larger sets of data. And then I always recommend evaluating, also doing a logical backup, which would be something like MariaDump or MyDumper. Something that is taking actually the records out of the database as insert statements so that you can easily put them back into a database. Sometimes that is unfeasible if we're talking about terabytes of data, but it gives us another attack point of restoring potentially lost data. Perhaps the logical backup would be the easiest way to recover a single table or single record rather than a file level backup with enterprise backup. time-lagged slave can also be very critical in recovering lost data. If you have users that accidentally delete a whole table or accidentally delete some records, instead of going through all of this backup process and replaying a whole backup, perhaps a time-lagged slave, a slave that has been told to not replay bin logs behind a certain time, that slave could be an easy access point to recover that data. Point-in-time recovery is also great, and it's a feature that we have in MariaDB where we can recover to that specific point in time using these backup features. And then we also have MariaDB Flashback, where we can roll back those transactions or roll back executed queries to get us back to a specific point. That can also be really critical and useful when trying to recover lost data. And one of my favorite new features is actually the replica rebuild max scale feature. So say that a drive goes bad on one of your replica nodes. How do you bring that back in sync? Do you personally go in and copy over all of the data and rebuild that replica manually? You can just issue a command on your max scale node and it will copy files from a chosen node to rebuild a broken node. Or perhaps you're increasing your node count and can use replica rebuild to build a new replica. Very cool feature, but very helpful when you're talking about downtime or failures and being able to recover very quickly from them, so you're not without a replica.
Good afternoon, friends and experts, and hello everyone who is online. Yeah, hi. So before I start, a little bit background about me. So my name is GP, right? So I am working in DBS for last 8-9 years, completely working in the database area. Before DBS, I was working in JP Morgan for about 10 years, and before that in IBM for 5-6 years, and even before that a few companies in the database area. So all of my life I am working only on the database area, right? So that is about me, and some information about the DBS who don't know about the DBS bank, right? So in DBS, you know, we always focus on the neighbors first, bankers second. You know, what does it mean, right? So neighbors first meaning, you know, we always concentrate on your priority, meaning like the family's priority is our priority, and whatever your personal goals are our goals. So that is what we aim for as a DBS bank. So because of, you know, we set our priorities right and customer focused, we have achieved so many awards, right? Like few are listed here: best bank, best digital bank in the world, best bank, in fact the safest bank. Last, I think 14 years, DBS is the best digital bank, best bank award we have received, right? And also, you know, some the revenues and everything. So since our priorities are set correct, and of course all the revenues by default it is coming into that, and also we are getting many awards for that. Right. So since we are talking about the journey of the DBS, moving from, you know, the old legacy structure into the digital technology, right? I want to share like where we were 10 years back in 2000, you know, before 2009 and versus current. If you look at 2019 or before 2014, right? So majority of DBS infrastructure is supported by, it is outsourced to, you know, the vendors like IBM or whoever it is. Right, but if you look at the current structure, right, so majority, more than 90 to 95% it is insourced, like we ourselves, we support, right, everything like infrastructure, data centers, network, applications, everything is supported by our own people. So in a way, DBS is beyond the banking, it is like a technology company. Right, so out of, even if you look at the total number of staff in the DBS, we have around 40,000 employees across the region. Out of that, you know, 10,000 employees are the technologists. So what does it mean is like, you know, every 4 employee, you can find 1 technologist. Right, so if you want to name the expert, definitely he or she will be available in DBS, right, any technology. Right, so here, the Gandalf, right? Meaning like, okay, since we are the technology, we are comparing against with the technology companies. So from the name, the Gandalf, it is a very fancy name, right? If you look at, we as part of the transformation journey, for this transformation journey, we want to give some fancy name to us, meaning like the Gandalf means a lot to us, right? So if you look at the name from the first name, G, Google, Apple, or Netflix. So here, fortunately, there is no company name called D, so we perfectly fit into that. So DBS is part of that Gandalf part. So what does it mean is like, when we started the journey in 2014 or 2015 onwards, whenever because we built this DNA in every employee's blood, right? Meaning like when we say, oh, this project is part of the Gandalf journey, it means a lot. Something similar to, the OpenWorks. When we say OpenWorks, it means a lot. I don't need to explain the background of, which are all the companies are joining in, who are all coming here from across the world. So everything it means, right? So similarly, when we say Gandalf, oh, this project is part of the Gandalf journey, even though you are in a, long queue, you can jump the queue, you can go in front, those kind of projects, anything, right? So that is what the Gandalf, we are part of the Gandalf, and we are a great success on making our digital transformation journey. So here, if you look at the different companies, we can't transform in one day or 1 month or, a couple of weeks. It will take some time. So even if you take the companies like Google, right? So Google, in fact, they started from 2000, and it took 5 years for them to transform completely, right? Similarly, Apple also, you see, it took around 6 years. Same for Netflix and for other companies. On the same way, for the DBS, we have started our journey in 2013, 2014 onwards. And by 2020 or 2019, we are completely transformed. That is why from 2020, in the previous slide, 2020 onwards, we have received many digital awards. And it is our continuous journey as part of this transformation. Right, and if you look at the normal typical banks, right? So normally, yeah, everyone wants to go cloud because it is a very fancy name, right? So yeah, I want to be part of the cloud. But we don't, as a DBS, we are not just going for the cloud just for the sake of moving into the cloud, right? We transform everything, meaning like including from the data center, network, even the hardware, and even the OS or databases, applications, people's mindset, everything. So there's a complete transformation journey. That is what we are the true cloud native. Right, so, and as part of this cloud digital transformation, the important topic is the resiliency. I think in the previous forum also many experts explained about the resiliency. But reliability is not equal to the resiliency, right? Assuming that even I have the 5 nines, right? 99.999, I have the resiliency, but still we are accountable for one failure in like maybe out of 100,000, right? You take maybe the airline industry, right? So in the airline industry, yeah, of course, maybe even if you apply the same logic, out of 10,000 or 100,000 flight, one flight is going to crash. Are you going to fly? Right. So that is what. So here, what does it matter is like, that is what, even if you take Airbus or Boeing, whoever it is, instead of flying with the 2 engines, they now fly with the 4 engines or whatever it is. So even if there is a 1 failure or 2 failure, if you are capable to come up and without creating any outage to the application or I am just translating into the database world, right? So if you are able to, handle the customers or handle the application without any failure, then we are okay, right? So here, because failure is an option, we can't prevent the failures, right? But how you are managing the failures, in the sense like how you are failing fast or the safest way to recover from the failures. So in DBS, as part of this journey, we have concentrated mainly on these 3 main areas, right? The hardware and the software and the people. Because as part of this journey, all 3 are important. Because even if you miss one area, I don't know whether you may succeed or fail, I don't know. But as in DBS, we have concentrated on all 3 areas like hardware and software and people, everybody, right? So that is not easy, right? Because if it is just on one department, it is very easy to achieve it. But if it is the complete application, and also, out of 40,000 employees, transforming and feeding this idea into their mindset, and they also need to run with you, right, as part of this journey, right? Just if it is only one team is running, I think it won't help. So that is what it means. So as part of this, I will be covering on the, the software with the MariaDB in later slides. Right, so on the hardware part, since we are the cloud native, and of course, we have to go with the commodity hardware, no choice, right? Because you can't go with the physical servers like or the mainframes or the area. So when you go with the commodity hardware, of course, the failure rate will be more, but it is more cheaper, and you need to manage the failures, or you need to come from those, you have to manage all those things. Right, but so these are all the challenges, right? So we faced these are all the challenges. Like if you look at the left side, on the traditional way, like if you take any physical servers or the mainframes, the failure rate will be very, very less, like less than 1% failure. But if you go to commodity hardware, of course, the failure rate will be more, maybe 5% or 7%, the failure rate will be more. And similarly, before we start the MariaDB, maybe 5-10 years back, our number of servers within DBS are around 3,000 servers, physical servers, right? But by the time we don't have any MariaDB, it is completely zero. But if you look at the current landscape, we have 40,000 plus OS, mostly on the VM, a virtualized machine. And out of that, we have 6,000 MariaDB and max scale servers. It is not just one or two, right? So overall, we have 6,000 plus, and maybe today it will be more because every day it is keep increasing, right? So you can't operate the way how you operated in the past, right? So the mindset needs to be changed, because if you need to have the even the skill set, like if you take maybe for the Oracle DBA or the SQL DBA, or even for the DB2, you can easily find somebody from the market. Maybe you put the cost factor aside, right? So definitely you can find somebody with the skill set. But in 2006 or 2010 or 15, if you want to find a MariaDB DBA, nobody is available, right? So even if you are paying more, nobody is available in the market, right? So that is our challenge, right? So how we are going to mitigate that? Those are all the challenges. And similarly, like the traditional way in the past, green zone meaning like a downtime, because I am deploying something, so formally I am getting a downtime from the application, downtime from the customers, right? So I can implement something. It is something like, you are bringing your car to the mechanic shop, so you can shut down the engine and you can do all the repair, right? So that is no problem at all. But today it is like an open heart surgery, right? You can't bring down any database down, right? So because the availability, right? It is utmost availability is important. Even a single second, the database can't go down now, right? Because most of our critical services like, the internet banking, mobile banking, and also many wallet applications, we used to call it as a PELA. And we have the cross-country, even the Singapore and Malaysia, it is cross-border. Even the same application can be used across the countries. So the database can never go down, right? So green zone is not equal to downtime hereafter anymore, right? So these are all the challenges we faced, right? And as part of this, then that is where the MariaDB coming into the picture, right? So we evaluated few databases, and MariaDB was fitting right as our expectations, right? So we concentrated mainly on these three areas. One is, the self-drive, meaning like the automated way of deploying or provisioning the databases, and the self-secure, because since we are the bank, of course, the security is the most critical concern, right? So it has to have the way to satisfy all the auditors, regulators, and even our internal audit teams, right? And also it has to have the self-healing power to, even if some permissions are granted, additionally it has to auto-heal by itself, and self-repair, and also the patching, everything, right? It has to be automated, because we can't operate any databases like the traditional way anymore, right? So now, right, as part of this, then these are all because we need to have now we have our vision clear. Yeah, we want to move on to the digital journey, and we want to, bring the MariaDB into the premise. But these are all our decision making and the key considerations for deploying the MariaDB in DBS, right? because as a DBS bank headquartered in Singapore, we have across all the regions, right? So all major markets, Southeast Asia, everywhere. So we have the data centers placed in all the countries, right? Because of the regulatory reasons, the data cannot be shared between different countries. Like even though we are headquartered in Singapore, if you need to access, or if we are supporting the other countries, then the data center must be on the local country. So here, whatever the automation or whatever the deployment we have, it has to support all the regionals. Because if you take Singapore, Singapore is a small country. So even if you have 2 data centers, primary and secondary, the distance is maybe 30, 40 kilometers max. Right, so even in this case, the network latency is maybe maximum 0.1 or 0.2 millisecond, even though you have the master on one data center and the replica on another data center, maybe 0.2 millisecond max you can get it, right? But if you take countries like China or Indonesia or India, we have the data centers across 3,000 or 5,000 kilometers away, right? So you have to think about it. You can't apply the same logic there also. Right. So, but when we are building the automation, you can't build automation, different automation for every country, right? So it has to be the same. So that is one of the important decision-making criteria. And also for, as a bank, the security patches and for the bug fix patches are highly critical. We can't run any database, right? Even if the bugs or the security fixes or any CVEs are released within 3 to 6 months, we have to apply that security patch. We have the stringent requirement from regulators, right? So, but having like 6,000 MariaDB and max scale, you can't, even by patching or upgrading, every day you have to do a lot, right? But you can't operate in that way. And similarly for the major upgrades, because if you take maybe the traditional databases, maybe those life cycle will be like pretty high, like 5 years, 10 years. But open sources like MariaDB or any database, maybe maximum 3 years or 2 to 3 years, right? So because every new releases keep coming up. And also since it is a commodity hardware and the ESX reboots or failures, very common, right? So whatever you are building on top of that, it has to have the capability to handle those failures. Right, and also for the load balancing, splitting queries, and adding the slaves on real time, right? And any data changes, if there are any accidental data changes, how we are going to handle. Because since there are many numbers of changes, or many, even though we have the CI/CD and other pipelines, so this is we are expecting that some data changes or some accidental damage may happen. So if at all, if it is happening, how we are going to handle that? Right, without downtime. That is also an important thing. And how many number of failures you are going to cope up with, right? So at least 2 failures you have to handle, and more, right? At least 2. So now, right? So these are all the facts we consider before we start to deploy or before we start to automate MariaDB in DBS. So we came up with a few deployment patterns, right? So as a bank, we have a wide variety of applications, meaning high critical applications, low critical applications, or the internal applications. There are many, right? So if it is a very low critical application, or if it is used only within the employees, right? So then that is we consider it is a less critical application. So for that we go with the standalone deployment. Even if it is a standalone deployment on top of the MariaDB, the bottommost. After that, above that we will have the app layer and the web layer, etc. But here, even though when we say it is a standalone, there is no other resiliency within the database layer, but on the backend, since we built all our VMs or the on the backend we have the other resiliencies like VPC resiliencies, and also we have the backup redundancies, right? So for the less critical applications, we always recommend to go with the standalone. But if the applications are highly critical, right, then of course you need to have the resiliency at the database layer. Like we go with at least one master, one slave, or one master, two slave, or we have few applications with one master, many slaves, right? So the main reason is at least even if the master goes down, the replica might pick up, and it will automatically promote the slave as a master within, even though here we mentioned 30 to 40 seconds, but in reality it is, I think, 25 seconds, right? So within 25 seconds, the other server is getting promoted as a master, and it is keep running. So the business is keep running it. right? So here you see the constraint here is like even though you have one master on many slaves, because all the databases are syncing real time or close to real time because of semi-sync or whatever other application type, right? But if you have the accidental data damages, then this method will not help. So that is why we are, even we have the method for handling the data corruption or even the accidental data damages. We go with the multiple replica copies. Right, so on top of master and the slave 1, 2, 3, etc. On top of that, we go with maybe few replica copies. One server will be running with maybe 6 hours, just an example. So that can be customizable, not a problem, right? Maybe 6 hours minus or 12 hours minus. So assuming that even because as a bank, we can apply or we can implement all the changes only during the night time, because daytime is highly critical, right? We are facing the customer. So nighttime, when you apply the change, even if it is 10 p.m., 11 p.m. or midnight, and next day morning, if you realize that, oh, something gone wrong, at least, you can recover from, or you can go back to the previous state. Yeah, so now you would have seen like where we started, right, and where we are today, right? So this is just a wrap-up slide. If you look at the complete journey, right, so the DBS journey. So before we start the digital transformation journey versus current one, right? So because before that, before we are starting the digital transformation journey, we have only less than 3% in the cloud native applications. But right now, more than 99% is already cloud native VMs or wherever it is. Similarly, the efficiency of the hardware also we have increased it from 1:5 to now 1:100, right? And also the data center footprint. Earlier we have like 28,000 square feet, but right now it is with very, very much a smaller space with the 7,500 square feet, right? And also now, even though we have 2 data center, we don't consider it as a DR data center anymore, right? So we consider it as active. We don't call it as a primary and secondary. We call it as a DC1 and DC2 because both are active at any point in time. And similarly, because of all the virtualization and other thing, our capacity to scale is like earlier, even 3%, 4%, now it is like 10 times we have enough capacity to grow. Right? And also the system provision also, if you look at earlier, like if the application team want to provision a server or create a database, normally it will take 4 months because to get a server, to install the OS and to install the database and harden it, creating everything, it will take 3 to 4 months minimum. But now maybe 5 minutes, everything is done, right? And also because of all this aggressive automation and because of the massive scale, earlier we used to have 1:50 as a system to DBA ratio, but right now for OS we have 1 SA for 1,200 OS, and even for the database team for the whole 6,000 plus database servers, we have only single digit DBA. Do you believe it? So our FTE ratio is 650 database servers. So if you translate into even database, every VM will have 6 or 7 databases, which means like a couple of 18, close to 5,000 databases for 1 DB. Yeah, so this is our complete transformation journey, right? So
okay, so thank you so much, GP.